Hello friends. Welcome to my channel. Let us now today all study about motion. What is motion? Motion is change in position of an object with respect to time. Whenever you see an object, suppose its position is changing with respect to time, we say it is in motion. Well, for defining motion, three things are important. First, change in position of an object. Second, time. Third is also a reference point. What do you mean by reference point? Well, by reference point I mean that you need to define whether the object is moving or not with respect to a reference point. I give you an example. Like if you and your friends are driving in a car, okay? Your friend, and one more friend is standing outside the car on the road, okay? So suppose the car is moving, then you can see your friend is not in motion, and your friend can see that you are not in motion. But when the reference point is your third friend, they can see, he or she can see that you both are moving with respect to the car, okay? One more example, like if you look out of your window and if you see a car is in motion, well yes, it's in motion. You see a person riding in a bicycle, yes, it's in motion, yes, it's in motion. But if I ask you, a building outside your window, is it in motion? You will say no, it is not in motion. Why? Because its position is not changing with respect to time. You are absolutely right. But this is when you are yourself a reference point. Now, if you go in space and if you look at that window, then that building is also moving. Why? Along with the rotation and revolution of the earth, that building is also moving, and that's why it's also in motion. So, what is motion? Motion is a change in position of an object with respect to time as well as the reference point. It is known as motion. Okay. Now, there are different types of motion, but what we'll be studying in this class is rectilinear motion and circular motion. What is rectilinear motion? Rectilinear motion, motion is in a straight line, it is said to be a rectilinear motion. That means when the direction of an object is not changing, the object is moving in one straight continuous line, it is said to be in motion. And what is circular motion? Circular motion is the motion of an object in a circular path. When an object is moving in a circular path, then it is known as circular motion. But when the object is moving in a circular path, its direction is continuously changing. Okay. There is one more thing. There is uniform motion and there is a non-uniform motion. What is uniform motion? Uniform motion is when an object covers equal distance in equal interval of time, then object is said to be moving with a uniform motion. For example, if an object moves, if a car covers 50 km every hour, first hour it is covering 50 km, second hour it is covering 50 km, third hour it is covering 50 km, fourth hour it is covering 50 km, then it is said to be a uniform motion. But does that happen in day-to-day life? No. Because when an object covers unequal distance in equal interval of time, it is said to be a non-uniform motion. Like you yourself must have experienced that if you go on a road trip, so in the first hour it might be that your car covers 50 km per hour. In the second hour it might cover 60 km per hour. Third hour you took a break and your car covered 35 km per hour. 35 km. But so when an object covers unequal distance in equal interval of time, it is said to be a non-uniform motion. Okay, so what we learned till now, we learned rectilinear motion, which is a motion of an object in a straight line. Circular motion, motion of object in a circular path. Third, uniform motion, when an object covers equal distance in equal interval of time, it is said to be uniform motion. And non-uniform motion, when an object covers unequal distance in equal interval of time, it is said to be a non-uniform motion. So, before we go ahead, let us try to understand what are scalar quantities and vector quantities. Well, scalar quantities, those physical quantities which has only magnitude, they do not have any direction, then those are called scalar quantities. For example, if I say mass, you might have gone to the market and have bought something per kg, like your mother would have told, beta, get me some 5 kilo potatoes. Okay, so 5 kg, that mass, it does not include any direction. 5 kg mass is same everywhere, and that is why it is a scalar quantity. So scalar quantity is the physical quantity which has only magnitude but no direction. So that physical quantity which has only magnitude but no direction is called scalar quantity. And for example, it is mass. Then we have distance. Distance traveled is also scalar quantity. It does not include any direction. Then we have speed. It is also a scalar quantity. Temperature. Temperature, if I say 34 degrees Celsius, it will be same. If I say 29 degrees Celsius, it will be same uniform throughout in whatever direction I say. So it is a scalar quantity. And then we have vector quantity. What is vector quantity? Vector quantity is that physical quantity which has magnitude as well as direction. Sorry. So that physical quantity which has magnitude as well as direction is called vector quantity. Example, if I say like force, the force is very important vector quantity. Like if you have a door which needs to be pulled, but if you keep on pushing that door, it won't get open. It will open only when if you pull the door. Okay, so force is basically a vector quantity because it needs magnitude as well as direction. If the direction is correct, the effect of force will be more. If the direction is wrong, the effect of force won't be helpful. That's why that physical quantity which includes magnitude as well as direction is called vector quantity. Example for it is force. We have weight, because weight is also one kind of force which is pulling us towards the earth. Then we have displacement. What is displacement? I'll get to that in a short while. Then we have velocity, acceleration. All these are example of vector quantities. Okay, the words velocity, acceleration, displacement will be covered up later in the chapter or later in the video. So let us move ahead. The next topic that we have is distance. What is distance? Distance is the total length of the path covered by a moving object. Total length of the path covered by the moving object. Suppose you go 3 km in one direction and then you turn at 90 degree and then you go 4 km in other direction. So the total distance traveled by you is 7 km. So distance is the total length of the path covered by a moving object which is known as distance, and this distance is denoted by f. In physics it is denoted by f. Yes my friends, now we are not denoting it by d, we will be denoting it by f. Okay, so the distance is the total length of the path covered by a moving object. It is known as distance. Its SI unit is meter. Its other units are kilometer and centimeter, millimeter. We all have used. 1 kilometer is 1000 meter. 1 centimeter is 1 by 100 meter. 1 millimeter is 1 by 1000 meter. So the SI unit of distance is meter, but its other unit are kilometer, centimeter, millimeter. Now, distance is also scalar quantity. That means it has just magnitude but no direction. Then distance, distance does not depend on the direction. As I already said, it is scalar quantity, so it does not need any direction. Then if an object is moving, then its distance won't be 0. Its distance won't be equal to 0. And one more thing, distance depends upon the path of an object. Distance depends upon the path of an object. Okay, when an object goes from one place to another, so the distance traveled will depend upon the path of an object. Suppose you have 3 ways to go from point A to point B, and suppose you take the shortcut, then the distance traveled will be less. But if you take some longer route, then the distance traveled will be more. So yes, distance is the total length of the path covered by a moving object. It's a scalar quantity. Its SI unit is meter. It depends upon the path of a moving object. And last but not the least, distance traveled by a moving object will never be equal to 0. Okay. Next we have is displacement. What is displacement? Well, displacement is the shortest distance between the final position and initial position of an object. Displacement is the shortest distance between the final position and initial position of an object. What do I mean? Suppose I am in point A to B. Suppose from A to B a person traveled 3 km and then from B to C he traveled 4 km. Okay, so the distance traveled will be equal to 7 km, but the displacement is the shortest distance between the final position and initial position of an object. Displacement is the shortest distance between the final position and the initial position of an object. If you calculate it by Pythagoras theorem, the AC will come out with 5 km. So displacement will be equal to 5 km. Displacement will be equal to 5 km. So displacement is the shortest distance between the final position and initial position of an object. So that's why whenever an object is moving, the shortest distance between its final position and its initial position, that will give me displacement. What it gives me? Displacement. Displacement is a vector quantity because it depends on the direction. It has magnitude as well as direction. That's why it's a vector quantity. Then its SI unit is also meter, just like distance. The SI unit of displacement is also meter, but other units are kilometer and centimeter. Then displacement does not depend on the length, on the path of an object. Suppose to travel from A to C, even if a person travels from A to point, suppose D, then D to E, E to F, and then it comes back to C. Even if it takes this route A, D, E, F, C, displacement will remain the same, which is 5 km. Because displacement is the shortest distance between the final position and initial position of an object. If distance and displacement are same, then if the person takes another route as well, then also the final position and initial position, the shortest distance will remain the same, and that will be the displacement of an object. Okay, then if final position and initial position of an object are same, then its displacement will be equal to 0. What does that mean? That if an object goes from A to B, suppose he travels 2 km, then from B to C he again travels 2 km, then C to D he again travels 2 km, and then D to A it again comes back to its same position, which is 2 km. Then the distance traveled will be 2, 2, 2, 2, which is 8 km, but its displacement will be equal to 0. Why? Because its final position and initial position are same. So whenever the final position and initial position of an object are same, then the displacement of an object will be 0. Okay? And displacement is also denoted by letter small s. Then you will say, then how we can differentiate whether it's a distance and displacement when we are both indicating by small s? In 9th standard right now, we are only going to focus the motion of an object in one direction. Okay, so when the motion of an object is in same direction, then distance and displacement will be same. Distance and displacement will only change when the direction of an object changes. When direction of an object changes. If the direction of an object changes, distance and displacement will vary. But if the direction of an object does not change, object keeps on moving in one single direction, then distance and displacement will remain the